It is considered to be one of the greatest instrumentation challenges ever. The extremely large telescope, which is currently under construction in Chile, will have a primary mirror with a diameter of 39 meters. Its main structure will weigh 3,700 tons. One of the key instruments of this telescope is the first light imager called MICADO, which is a near-infrared camera. I visited the Space and Astrophysics Instrumentation Research Lab at the Paris Observatory in Meudon. The lab, called LESIA, has contributed significantly in the development of the adaptive optics system of MICADO. I asked Jan Kleene, who is the co-investigator of MICADO, about how the adaptive optics system works as well as the scientific objectives of the extremely large telescope.
So why do we use adaptive optics on these big telescopes? To answer this question, we have to understand why we are building a larger and larger telescope. Actually, we do this to have more and more light because we want to observe objects that are very faint in the universe. It can be very distant galaxies, but it can be also very faint solar system objects, planetesimals or asteroids. And for this, we need to have a lot of photons, and to have a lot of photons, we have to build larger telescope. But unfortunately, on the Earth, on the ground, we suffer from the turbulence of the atmosphere, and this turbulence degrades the quality of the images that we have on the ground. So to compensate for this effect of the turbulence, astronomers and others have thought about building a system that allows to compensate for this deviation of the light. And for this, we need three subsystems in the adaptive optics system. We need a sensor that is able to measure the deformation of the light. We need corrective optics, and usually it is mirrors that have actuators below the surface, the reflective surface of the mirror, and that change the surface of the mirror and then make the image better. And the last one is a very powerful computer that allows to compute the commands to address to the mirror from the measurement of the sensor.
And finally, what are the scientific goals of the extremely large telescope, and how does it compare to the James Webb Space Telescope?
So the ELT will cover a lot of science cases. First, for example, it will observe very distant galaxies to understand the formation and the evolution of these very first galaxies in the universe. It will observe also exoplanets, either closer to their host star or more distant. Or it will observe very faint and small bodies in the solar system. So there will be a lot of science cases covered by the ELT. And regarding the comparison with the JWST, there will be synergies between the two observatories. But one advantage of the ELT will be the resolution that the ELT will be able to reach thanks to this very large diameter.